Hey guys, second video in equivalent forms of exponential expressions. This one looks like a doozy. I know a lot of you are probably already freaking out about how this even looks when it sets up. That's okay. Let us break this thing down step by step, and it actually doesn't turn out to be too bad of a problem when we do that. If you remember, if you watched video number 1 on this, you know that we either need the orange, the exponents, or the green, the bases to be the same. In this case, we have the green, the bases to be the same. What I did, for those of you that are wondering, is I took this problem here. If you remember, a subtraction problem in the exponents. If the exponents are being subtracted, then the bases stay the same. 64 was the base, 64 on top, 64 on the bottom, and you make it a division problem. So I took this first part, 64 to the t to the third power, that I rewrote up here, that's on top, minus, right? Minus means move it to the bottom. I moved it to the bottom as 0.5t, but I had to have the same base, right? That is where that guy's coming from. So this is the equivalent expression to that. If you notice here, I rewrote it in blue now. So I took this green and orange problem and I rewrote it in blue. And all I did to rewrite it in blue was to take this part here, 64 to the 0.5 power. 64 to the 0.5 power, it just means the square root of 64. The square root of 64 is 8. So I rewrote this problem as this to look like this. I did this for a couple of reasons. One, we can take a look here. That is not the same. 64 t to the third over 8 to the t is not the same as 64 t to the third over 8 squared t. One of the reasons, if we were to work backwards from what I just said, this is the square root of 64, right? If we were to work backwards, 8 squared is 64. So this would be 64t to the third over 64t. That is not what I have over here. I have over 8t, so this one is not equivalent, right? This is also not equivalent to this. It's very close. Notice the top is 64t to the third, like I wanted. The bottom is 8t, 8 to the t, like they want, but this is a multiplication problem. This would be very similar to something if we had a plus here. Instead, we have a minus. So since it's a minus, that created a division problem. If this was a plus, this would created a multiplication problem, and then we would have been fine. Which makes us then wonder, what about this last thing? Notice on this last thing, 8 to the t is already on the bottom. 8 to the t. T to the third is already on top. T to the third already on top. Now I just have a 4 somehow in there. So why do they have a 4 in there? What they did is they took this 64 here and they rewrote it. Let us rewrite it. They rewrote that as 64, which is the teal color there, as 4 to the third power, because 4 times 4 times 4 is 64. So they rewrote this 64 as 4 to the third, and then they just copy down the rest of the problem. That does work. That does make this equivalent. One question that people have all the time is, why does this 3 only apply to the t? And it has to do with parentheses, right? This, if this was in parentheses, if this was 3t inside of parentheses, so if it was like this, 3t to the third, that is different, right? That is not the same as 3t to the third. This is just a review from before. This problem over here, 3t is to the third power. 3t times 3t times 3t. Over here, this is 3 times just the t to the third power, or 3t. Let me know if you have questions.